Hello friends, good morning. Welcome to my amazing sa pyara sa channel Physics Universe. I hope you are all fine at your home and we are enjoying this online lectures. So guys, today's our topic is Faraday's laws of induction. Now, earlier we discussed about Faraday's experiments. Faraday had 3 experiments. In these 3 experiments, Faraday's conclude that in the first experiment, there is a motion of a magnet according to coil. So in that experiment, coils remains constant, coil have no motion, and just bar magnet have its motion towards the coil and away from the coil. So Faraday's in that experiment just observe that whenever if there is no relative motion between coil and magnet, then there will be no deflection in that galvanometer. So we get deflection only when the bar magnet is moving in relative motion with the coil. So why this happened? So Faraday's just give that conclusion that whenever there is a change in magnetic flux, due to change in magnetic flux in this coil, there is induced EMF in this coil. So induced EMF will be produced in this coil, and due to that induced EMF we get induced current. So that's how we get current in this coil due to the changing magnetic flux. Clear? Okay. Now in the second experiment, Faraday just moving 2 coils. So there is a relative motion between the coils. Now due to the first coil which have the electric current, so due to that electric current we get magnetic field, and by relatively moving their coil we get magnetic flux which is changing. So due to the motion of this coil we get changing magnetic flux, and due to the change in magnetic flux we get induced EMF inside the other coil. Due to that induced EMF we get induced current, and that's how we get galvanometer deflected. Clear? So that's the second experiment, and now we are moving to third experiment. Again there are 2 coils, one is connect with battery and another is connected with galvanometer. Now Faraday just whenever switch on or off, current is increasing and decreasing. So because of on off the switch, current is just increasing and decreasing. Due to the change in current we get changing magnetic field. Due to changing magnetic field we get changing magnetic flux. Due to changing magnetic flux we get induced EMF to the other coil, and due to that induced EMF we get induced current in that coil which is connected with galvanometer. So that's how galvanometer is deflected. So in these three experiments, Faraday's just conclude that we get electric current due to changing magnetic flux. So Faraday just given this law by their experiments, and that is our induced EMF is directly proportional to the changing magnetic flux with respect to time. Here, so proportionality removed, so we can write E is equal to minus d phi by dt. Here it is also minus. Now why is there negative sign inside this formula? Because this EMF is just decreasing or increasing with the change of magnetic flux. So here we can also write E is equal to this equation is for only whenever there is only one turn in that coil. If we have n number of turns which we get induced EMF, then E is equal to minus n d phi by dt. So yes, there is a question arise that why is there negative sign in this formula? Because this EMF is produced itself due to the change in magnetic flux which opposes this EMF itself. मतलब कि यहाँ पर जो मैग्नेटिक फ्लक्स इंड्यूस हुआ ना, जो मैग्नेटिक फ्लक्स हमें मिला, वो वही खुद इस ईएमएफ को अपोज करता है. वो हम लोग आगे देखेंगे लेंज लॉ में. बट यहाँ पर सिर्फ नेगेटिव साइन इसलिए है क्योंकि ये इसको अपोज कर रहा है, इसीलिए यहाँ पर नेगेटिव साइन मिलने वाला है. क्लियर? सो दैट्स अवर Faraday's law equation. Again, what is E? It is induced EMF, and is the number of turns in the coil, and d phi by dt is the change in magnetic flux with respect to time. So that's our topic, Faraday's laws of induction. That's it for today, guys. Thank you so much for listening my video lectures till the end. That means a lot to me. Please like my videos, subscribe my channel.